Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
This one question lost more marks than any other on last year's papers. Students wrote down a vector, but it was the wrong kind. They used a position vector where a direction vector was needed and lost a whole method mark. Sound familiar?
Yeah, I remember that. It felt like the exam was asking for an arrow and I drew a map instead.
Okay, promise for the next 10 minutes. I'll show you the single clear difference between position and direction vectors, how to write vector equations of lines the examiners love, and we'll walk through a full 4-mark example, step by step, so you can write every line that earns marks, plus a 3-point checklist you can use in your next practice. Let's start simple and build up. First, the concept. Imagine a point on a grid. A position vector tells you where that point is from the origin. For example, the position of point A might be written as the column vector 2, 3. That just means start at the origin, go 2 right, 3 up. A direction vector, on the other hand, tells you how to move from one point to another. It gives direction and relative size, not the location. If a line moves 3 right and 1 down each step, the direction vector is 3, -1. Important, position is a location, direction is a step. Don't swap them.
So, position says, here's a point, and direction says, and then go like this.
Exactly. Now, notation you should use in exams, write position vectors as column pairs or bracket pairs. For example, R equals 2, 3, or R equals 2, 3, when speaking. For a line, use a vector equation, like R equals 1, 2 plus T times 3 minus 1. Read that aloud as R equals position vector 1, 2 plus T times direction vector 3 minus 1. What does that mean geometrically? As T varies, you trace every point on the line. T equals 0 gives the position point 1, 2. T equals 1 gives 4, 1. T equals 2 gives 7, 0. You can see the movement in concrete coordinates, no mystery.
Operations. Add vectors component-wise. Multiply by a scalar by multiplying each component. So 2, 3 minus 1 equals 6 minus 2. Simple arithmetic leads to the points on the line.
How about magnitude and unit vectors? I always mess up the root.
Good question. Magnitude, the length, of vector AB is the square root of a squared plus b squared. For example, the magnitude of 3 minus 1 is the square root of 9 plus 1 equals the square root of 10. A unit vector has length 1, so to make a unit vector from 3 minus 1, divide by its magnitude. Unit vector equals 3 over the square root of 10 minus 1 over the square root of 10. Write the square root in the denominator. That keeps exactness, and examiners prefer exact answers unless the question asks for a decimal.
Tip. Keep the signs with their components when you divide. A negative stays negative. That small sign error is often where marks go.
Now, the worked example. We'll treat a typical 4-mark question you might see. I'll read it, then we'll build the answer line by line.
Question. Find the intersection of the line through A with position vector 2, 1 and direction vector 1, 2, and the line through B with position vector 5, minus 1 and direction vector minus 2, 1. Show your work.
Step 1. Write both vector equations with parameters. This is a method mark. So write R equals 2, 1 plus T into 1, 2 and R equals 5 minus 1 plus S into minus 2, 1. Say, let T and S be real numbers, or just show the two equations clearly. The examiner needs the equations to award M1.
So 2 equations, 2 parameters. Got it.
Step 2. Equate components. From the first equation, the x component is 2 plus t equals 5 minus 2s. The y component is 1 plus 2t equals minus 1 plus s. Write both equations down. That gives you the system to solve. Examiners want both components shown. That's another method mark possibility. Step 3. Solve the system. I'll solve it quickly. From the x equation, 2 plus t equals 5 minus 2s, so t equals 3 minus 2s. Substitute into the y equation. 1 plus 2 times 3 minus 2s equals minus 1 plus s. That gives 1 plus 6 minus 4s equals minus 1 plus s. So 7 minus 4s equals minus 1 plus s. Bring s terms together. 7 plus 1 equals 5s, so 8 equals 5s, hence s equals 8/5. Then t equals 3 times 2 8/5 equals 3 minus 16/5 equals 15/5 minus 16/5 equals minus 1/5.
So t is negative here. Is that okay?
Perfectly fine. It just indicates a point on the line, which can be in either direction from the position point. Now, final step. Find the intersection point by substituting t into one line. r equals 2, 1, plus minus 1/5, 1, 2, equals 2 minus 1/5, 1 minus 2/5, equals 9/5, 3/5. That is your answer. If you show the substitution and the resulting coordinates, you pick up the accuracy mark. Let's map these steps to marks. This is a typical 4-mark layout. M1 for writing both vector equations, M1 for equating components and setting up the simultaneous equations, M1 for a correct substitution or elimination method leading to the parameters, and A1 for the final coordinates, exact form. If you can't finish the algebra, make sure you at least set up the equations. That first M1 is often free marks.
What do examiners complain about most in these questions?
3 common errors. 1. Swapping position and direction. 2. Not defining the parameter. Write let t equals or show the equations. 3. Solving only one component and forgetting to check the other. Examiners sometimes note incomplete method when they see only one component solved. So write both component equations and carry through at least one elimination step. That preserves method marks.
Notation matters. Use clear commas or column vectors, keep your signs, and label your parameters. If you show r equals 2, 1 plus t, 1, 2, that is textbook notation, and examiners immediately know what you're doing. Quick win. A 3-point checklist you can use in every vectors question. 1. Always define your parameter. Let t equals, or let r equals position plus t direction. 2. Label which vector is position and which is direction, clearly. Write them on separate lines. 3. Substitute your parameter back in to check the other component, and use Pythagoras to check magnitudes when required. This takes 20 seconds and catches most slips.
Any speed tricks for unit vectors during revision?
Yes. Don't decimalize. Leave the magnitude as a square root. If the vector is AB, compute the mag as square root of a squared plus b squared, and write the unit vector as a over square root, comma b over square root. If the question asks for a unit vector in the same direction, that exact surd form wins full accuracy marks and is quick to write. Final practical note. If you get stuck halfway, write the vector equation clearly and at least one component equation. That usually secures M1 and keeps you in the game. Marks are there for the taking. Let that sink in. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and printable vector worksheets at jcacademyonline.co.uk. Visit the show notes for the direct link to the 20-question vector worksheet and full worked solutions pack. Until next time, trust the process and nail that exam. Stay curious.